tax problems, which I know cause a lot of people problems. So first off, we had a question. So some of you saw this problem. It looks like this. And the question asked by someone was, why is section D on that graph that's labeled, why is that the producer surplus after tax? So the best way to answer this, I'm sorry if it's a little dark today, but the best way to answer this is making sure you understand what the graph is. So we've got our demand curve, supply curve. This is our price at equilibrium if we have no tax. This is our quantity at equilibrium if we have no tax. So we have two options if there's going to be a tax. One is we can shift the supply curve, and we could shift it all the way up here to represent the excise tax. In which case, this would be the price the consumer pays. This would be the quantity that the consumer receives. But the consumer doesn't get all that money. The amount that the tax shifts has to be paid, right, by the producer. And so the producer actually receives the lower price. So this is producer price consumer, price producer. So by definition, consumer surplus is all of the area above the price line and below the demand curve. So A would be the consumer surplus after the tax. By definition, producer surplus is everything below the price line but above the supply curve. Well, in this instance, the producer only receives the price down here. And so this area right here that's D is the only amount that fits that requirement, below the price the producer receives and above the supply curve. So as long as you understand that, you're okay. So let's erase that one. Let's go to the next question. And I'd like to thank Kitty, I think it's Bludoff, and Martha Hernandez. They're the ones who proposed questions this week. And I tried to get to them last week before I went out of town for a business meeting, and it just wasn't going to happen. So anyway, more than happy to extend homework out for people if they need extra time. So next question was the Canadian Tire Company. And I'm going to draw the graph, but if you're looking for this one, this is the Canadian Tire Company. And I'm not going to label all the numbers on the graph. I'm just going to kind of put up the graph that they have, and then we'll talk abstractly about it. So this is kind of the graph you're shown, and it says, suppose that the Canadian government decides to place the excise or sales tax of $20 per tire or producer of automobile tires. Previously, there was no excise tax on automobile tires. So then the question asks you to shift the appropriate curve on the graph to demonstrate the new equilibrium. Well, the tax is on the producer, so that means the supply curve is going to shift, and it's going to decrease supply or increase the curve, right? I tend to say decrease supply. And so how do you figure out how far to shift it? Well, the problem tells you that at equilibrium without a tax, the price is 90, and the quantity is 4, if I wrote down my notes correctly. So it looks something like this. So what you want to do if there's a tax is you need to shift up the supply curve by exactly $20. Well, just so happens in the problem, it tells us that the end point for the supply curve is one quantity at 60. So we're going to shift the supply curve until the initial one quantity is at 80. And that'll shift up this corresponding curve on the supply curve by 20 post-tax. And then we're going to look for the new equilibrium, and the new equilibrium will occur somewhere up here. So if you look at the numbers that they give you on the graph, the first question says, what is the price consumers pay for a tire post-tax? So you're actually just going to go up here, and what you'll do is you'll take it over the dotted line, and you're going to find out that the price is $100 after the tax. And then it says, what's the price that the producers receive? Well, the producers, they don't get to keep the 100. They have to pay the government 20 bucks. So 100 minus the $20 tax is $80. So the consumer pays 100, the producer pays $80. The key thing to understand here is how to shift the curve by 20 units. You're literally finding a place. And some of the graphs, they don't give you nice endpoints. So you have to choose something on the interior. But you slide up by $20. Everywhere along this curve, it's $20. And it's a straight line. Not that I draw all that straight. But anyway, that's how to solve that. And there's a whole mess of problems like this. So when the problems ask you to shift the curve, it's really probably more important than anything to know how to shift the curve. As opposed to in the supply and demand problems where you could just kind of shift the curve. Here we actually have to be careful with the amount we're shifting it by, right? Because we're putting numbers to these problems. So in a similar vein, a question that came up was the question on potato chips. Now the potato chips question, well, we can go through it, but the reality is it's very similar to the other one. It's what do you shift? And so this one actually has two series of graphs. I'm going to lay these out. And just writing out these curves. And both of the graphs represent the exact same curve. So they're two duplicate graphs. And so the problem says, suppose that the government levies a tax, and the tax is $1. Suppose this government levies the tax for the manufacturers for each bag of potato chips they produce. So this one, when it's on the producer, we have to shift the supply curve, and we're going to shift the supply curve up by $1. So we move this point from 0 to 1. We shift up the graph. We get our new supply curve after the tax. All we have to do is look for the price, and the price ends up being $2, and the quantity ends up being $1 at that. Is it 1? Oh, no, sorry, it doesn't ask the quantity in this one at all. Sorry, it says, what's the price paid by the consumers? And its price is $2. Then it says, what's the price received net of the tax per bag by producers? Well, the producers are going to get the $2 from the consumer, pay the government $1, so 2 minus 1 is 1. So the producers receive $1. Then the question says, assume the consumers have to pay the tax. Now what's going to happen? So now we shift the demand curve down, and we take it from 2.5 to 1.5. And we shift down this curve, and it should end somewhere around 6. And if we follow this over, we learn that the consumers are paying $1. And so it says, what's the effective price paid per bag by consumers after the consumption tax? Well, they pay $1 to the producers, and then they have to pay the tax, which is another $1, so they pay $2. What's the price net of tax what's the amount of price received without the tax by the producers? $1. So again, it's going to be 2 and 1. So it's pretty straightforward. Just have to switch curves. Remember that someone always has to pay the tax. If the producers pay the tax, then they take the money from you, and then they pay the government the amount of the tax. So what they actually receive is a lower amount. If you pay the tax, you pay the producer the lower price, and then you have to send the government a check for the difference. So as long as you remember that, you should be fine. And as I said, these are all kind of a similar class of questions. So I'm pretty certain where people are stuck is they're not shifting the right curve, or they're shifting the right curve, but they're shifting the curve in the wrong direction. In fact, because as that problem illustrates, you can shift the supply or the demand curve. The result's the same. But in all likelihood, if you're getting these wrong, you're shifting the wrong curve, the wrong direction, or you're forgetting that someone has to pay the tax. And so if the producer pays the tax, they don't get to receive all of that money. So a lot of this is just reading the graphs, shifting things by the appropriate dollar amounts. The next question was the bungee jumps and extreme land question. This question also comes with the graph. This one is a little tricky, and I'll show you. It's not as hard as you might think. So I'm going to lay this out. 42. So this graph, the numbers are important on it, but I'm not going to be able to draw all the numbers for better or worse. But what I want to illustrate is some of the key points here. So first off, equilibrium on this graph occurs at 40,000 units or 40,000 bungee jumps at a price of 120. So you end up with a graph that's something like this. Now I labeled the price over for you, and this the quantity down. And so what this says first is if the government's tax revenue would be, so what would the government's tax revenue be if it imposes a jump of $80 on each jump? So to figure out this one, what you have to do is look at the distance at various quantities between the graphs. And what you're looking at is when this distance between the graphs equals $80, or in the next question, 100, or sorry, the next question 40, and then the next 120. So you take the 80, when it's a spread of 80, you track down and you find out that it was 20,000 jumps at $80. So we'll keep this. So at a tax of 80, okay, then if you do the same approach and you look at 40, at $40 tax, the spread between the supply and demand graph being 40, then you're going to trace it down and you'll find out your quantity is 30,000. And the last one is at a tax of 120. And at 120, we end up with 10,000 jumps. To get revenue, we just take the tax times the number of jumps. And so we should get 1.6 million. At $40 tax, we should have gotten 1.2 million. And at $120 tax per jump, we should get 1.2 million. So the principle that's illustrated in this question is that if you set the tax rate too high, you can actually reduce tax revenue. There is an optimal amount of tax. I'm not a big believer of this, but in macroeconomics, we call this the Laffer curve, right? And so the idea is that if you increase taxes beyond this point, so this is tax rate, you decrease revenue. And this tax revenue down here. Not that anyone can read my sloppy writing today with where I am. So the idea is you increase tax too much, you can actually decrease the revenue because as tax rates go up, people buy less items, right? So it's important to make sure your taxes are set appropriately. The trick on this one, once again, was figuring out that the tax rate is just the spread between the curves. Now, you could have just shifted the supply curve up and then checked the new quantity, or you could recognize that the distance between the supply and the demand graph represents the size of the tax, right? And so if you're doing your tax revenue, and I'm going to do a simple supply and demand graph here, if the supply curve shifts down because of a tax, like here, this line right here going straight down from the new equilibrium to the old supply curve, that represents the tax revenue, or sorry, the tax, and the tax revenue is just this shaded rectangle. So if you remember that, then all you need to look for is the endpoints of the triangle for dead weight loss, right? And so this distance here is the amount of tax. And the shaded area, the area of that rectangle, is the tax revenue. So we're looking for a tax of 80, a tax of 40, and a tax of 120, right? And that would represent various shifts of the supply curve. So that one is a little trickier. It really requires you really, once again, know your math and know how to read a graph, how to interpret a graph. A lot of this comes down, a lot of your ease on doing this really comes down at the end of the day to how you were trained to work with graphs when you learn math. And, you know, for better or worse, we're trying to remediate some people's situation, but it looks like people are actually doing pretty good. And this is, by the way, it's not easy homework. I'm not going to say that. And some of it is, you know, once you guys see me do the answer, I hear a lot of, oh, really, it was that easy. So next question someone proposed was the jack-o'-lantern. This very similar. The only difference, and this one we have two graphs. We have the jack-o'-lantern graph and the witch hats. And the difference here is it's a question about elasticities. And so we have two demand curves with fairly similar slope, actually fairly inelastic slope. And then we have a supply curve that's fairly elastic and a supply curve that's inelastic. Now, I'm not going to go through and solve these, but what you have to do, these problems, the only trick here is that the problems aren't as clearly delineated on the numbers, so you have to make a little guesstimate, but it does let you shift. And so you're going to shift up the supply curve for jack-o'-lanterns by $10 if that's what it tells you to do. So you move this from here, you move any point that crosses a number that you recognize on price, and you move it straight up by $10, and then you're looking at what the new quantity is where it intersects, and you should have some lower quantity. And then what you're going to do is calculate the dead lot. So then what you're going to do is you calculate the dead lot's weight for that region, right? And so what you're going to have to do is calculate the area of a triangle. Now, once again, it's a little tricky. So what's happening here is when you shift up the graph, and let's think about the one for jack-o'-lanterns, I'm going to look at the numbers. You know, I chose to shift the point at 10 and 20,000 all the way up to 20 and 20,000. And so we shift up the, 20 and 20,000. So we shift up the curve all the way to there, and we get that we have 20,000 units times $10. So that's times 10, which equal to 200,000. And then to calculate the area of a triangle, we divide by 2, which is $100,000, or in dead weight loss, right? So we're just calculating this triangle, and what we do is we know the tax, so we know the distance from here into here on the price is equal to 10, and then we need to calculate the change in the quantities. And so we know we went from 20,000, so we went from 40,000 to 20,000, so that's a difference of 20,000. So we went from 40 to 20,000, and so the difference is 20,000. That's where I get this number. Multiply times the tax, right? And I'm getting my base times my height, and then I divide in half to get the area of the triangle. So base times height, 200,000 divided in half, that's 100,000 dead weight loss on that problem. For the witch's hat, we have to do something similar where we're going to move up. I chose the point somewhere around 30,006, so it became 30,016. So the difference is 10,000, 30,000 to 40,000 is a 10,000 difference. So 10,000 times 10, 100,000 divided in half, 50,000 is the next answer. And then what you learn is the inelastic supply curve creates lower dead weight loss, right? The steeper the supply curve, the more inelastic the supply curve, if we're representing things that are like an airline rate ticket or housing market, then what we're saying is there's not a lot of dead weight loss from imposing taxes on things with steep supply curves, right? By the way, same thing's true for a demand curve. Any inelastic curve produces less dead weight loss. Try it out on your own. Draw a perfectly inelastic supply curve, and then see what happens. You impose a tax. That means all the producer, consumer surplus, or tax revenue goes somewhere. There's no waste in the system with an inelastic curve. So the last question that people had, let me erase this, was the one where we had the table, and I need to replicate this table really quick, but this was shots of cappuccino. And so what I'm going to do is add a thing to this table. 1, 2, 3, 4, 5. Now this problem for all of you had different numbers, but we have the consumer, and I'm just going to use their first initials. So I'm going to have Stephen S, Terry T, Rachel R, John J, Christine C. And then we have their willingness to pay, or I'm going to label this WTP. That's how much they're willing to pay. And the problem I pulled up had 325, 3, 275, 250, and 225. Then the next one was producers. And I'm just going to use the first initial of the producers. We have M for Mojo, J for JC, P for Pacha, R for Ruta, Inca, and A for Anderson. And we have their cost of producing. Okay, and the costs I had were 175 to 250, or sorry, 225 first, 250, and 275. So here's the actual layout of the table. Now you notice the only thing I added was quantities. There's two methods to solve this. One method, the easy method, is to say what we know is that at one quantity, there's the same price between producers and consumers. So consumers are willing to pay what the producers do. There's only one place where this happens. At 4 quantity, we have 4 consumers willing to pay at least $2.50 and 4 producers willing to sell at $2.50. You could also have gotten this by graphing the points. You could graph these. This is your demand curve. This is your supply curve, is your costs. And if you graph these, what you would have found, and really you would have a stepwise function. What that means is it goes like this. But I'm just drawing it as continuous. And what you would have found is that 4, the intersection at 4 was 2.5. So the price at equilibrium without a tax is $2.50, and the quantity is 4 cappuccinos. So then the question says, there's a tax of $1 put on the consumer or the producer, right? Let's see. Oh, it's a tax on the consumers. So what's a tax do? It effectively decreases demand. So now we know that this person's demand, so this is willingness to pay after tax, and I'm just creating a new column, is $2.25, $2, so $3.25 minus $1, $3 minus $1, $1.75, $1.50, $1.25. So now I'm going to do the same thing. I could graph it again and just shift down the supply curve by $1, or what I could do is compare, and I go, well, 1 unit is $2.25 and $1.75, so they're still willing to trade. 2 units is $2 and $2. So the transaction will happen after a tax at 2 quantity and 2 for the producer, right? And they're going to sell at a price of $2, 2 units. At quantity 3, someone would be willing to pay $1.75, but they're going to charge $2.25. That transaction can't happen. So now the final question is, what's the deadweight loss? And this is the hard part. What you have to do is calculate producer and consumer surplus before the tax and after tax. How do you do that? You see how much people benefited. So let's start with the consumers. Initially, before the tax, this guy was willing to pay $2.50 and he paid $2.50, so there's no benefit. This person was willing to pay $2.75 and they paid $2.50, so they got 25 cents. This person was willing to pay $3, but they paid $2.50, so they get 50 cents. This person was willing to pay $3.25, but they paid $2.50, they get 75 cents. And we add up the 25 plus 50 plus 75, and we find that the consumer surplus before the tax was $1.50. We do the same thing for the producer surplus, and we find the similar result, which is $1.50. $1.50 plus $1.50 equals $3 in consumer and producer surplus before the tax. After the tax, we calculate the same thing, and we end up with a producer surplus of 25 cents, right? The price was $2, so this guy gets no benefit. This guy gets 25 cents. And a consumer surplus, 25 cents. The first person was willing to pay $2.25, but they only had to pay $2. So we add up that, and we find out that it's 50 cents. Now, deadweight loss also requires we know tax revenue, and we know that the tax was 2 units of quantity times $1. So the tax revenue was going to be $2. Okay, so tax revenue to them is $2. So now deadweight loss, and I'll write this up here, is equal to the producer and consumer surplus before the tax minus the producer and consumer surplus after the tax, 50 cents, minus the tax, plus the tax revenue, so $2. So we solve this, and it's $3 minus 250, which is 50 cents, and the deadweight loss ends up being 50 cents in this problem. Okay, so that's everything that I wrote so that you can kind of stare at it and see. You also could have calculated the area of the triangle, the deadweight loss, but it's a little more difficult because it's a stepwise function. It's a stair step down. It isn't actually as easy to calculate because it's not a continuous triangle. It's not base times height divided in half. It's a little trickier to calculate a discrete area underneath a curve. You actually have to do what I did and calculate the actual area. So that's all of the questions people had on taxes. As I said, I recognize these are challenging. We'll let you know the next section I put up, consumer utility, for most people seems to be a little easier. And also when we get to the following week for supply curves, that seems to get a little easier for people as well. When so what we're looking at over the next 3-4 weeks is we're looking at why is the demand curve downward sloping? What's the theory and philosophy behind that? And we're also looking at why is the supply curve upward sloping? What's the theory behind that? And so a lot of what comes in the next few weeks is very easy. It's a lot of formulas to learn and things like that. But the formulas don't involve difficult or complex mathematics. They're fairly straightforward. So anyway, I hope this was helpful for all of you. If you need a little extra time to get through those tax problems, let me know. I haven't heard too much from people on the producer-consumer surplus. I think that homework is actually easier. But if you need more time on that, let me know as well, and I can give you a little more time. We've got, starting next week, we have 9 more weeks in the semester plus spring break. And I know from my online classes, people tend to work through spring break. So you effectively have 10 more weeks. And really, I'm happy with where we are. We're about halfway through the material I want to cover, and we're through the more difficult material at this point. So you guys that have made it this far, you're doing great. And just keep up hard work. As long as you work hard and you put in the effort, you'll do fine in the class. And just be sure to always let me know when you have problems. I don't mind doing these videos. They're just, my schedule this semester has been so hectic, it's been getting hard for me to find the time to do them on days. My meeting schedule picked up for some reason. So anyway, but what it is what it is. So I'll give extensions until I can get videos done because, I'm not going to make you guys responsible for questions you asked that I haven't answered yet. Talk to you later. Have a good night. Bye.